This is the end, beautiful friend. This is the end, my only friend. The end of our elaborate plans. The end of everything that stands. The end, no safety or surprise. The end, I'll never look into your eyes again. Can you picture what will be so limitless and free? Desperately in need of some stranger's hand in a desperate land. Lost in a romance, wilderness of pain, and all the children are insane. All the children are insane, waiting for the summer rain. There's danger on the edge of town. Ride the King's Highway, baby. Weird scenes inside the gold mine. Ride the highway west, baby. Ride the snake, ride the snake to the lake, the ancient lake, baby. The snake is long, 7 miles. Ride the snake. He's old and his skin is cold. The West is the best. The West is the best. Get here and we'll do the rest. The blue bus is calling us. The killer awoke before dawn. He put his boots on. He took a face from the ancient gallery and he walked on down the hall. He went into the room where his sister lived, and then he paid a visit to his brother, and then he walked on down the hall, and he came to a door, and he looked inside. Father, yes, son, I want to kill you. Mother, I want to. Come on, baby, take a chance with us. Come on, baby, take a chance with us. Come on, baby, take a chance with us and meet me at the back of the blue bus. Do not blue rock on that blue bus. This is the end.
All right, so today is our final review. We will not have a live stream or a class on Friday. And I brought along fall 2023's final exam. And it's pretty much very much the same format as the one that we looked at on Monday. You're given a problem statement and a bunch of starter code, and then you have to produce several reports, okay? So the problem statement here is that we have LSP is a large pharmaceutical company that's administering various doses in milligrams of 4 experimental medications: no-diethol, Keep-Liva, Expensive, and Placibutol. These are just made up. To thousands of patients over several years. They're now at the end of their medical trial, and they need to compile several reports. So the data is given to you in the following format. It's a CSV file containing a UUID. I think we briefly talked about those before. It's a universally unique identifier. It looks something like this, right? So it is like a randomly generated, but then cryptographically randomly generated bit string, and it's in a hexadecimal format here. The patient's first name and last name, their blood type, AB or O, and a date time stamp in ISO 8601 format when they were administered the dose. And then finally, the medicine and the dosage. So if you take a look at a full record over here, right, you'll see that Jeffrey Anderson has blood type O, and on that date he was given Kepliva, 140 milligrams. But you can see here that Jeff Anderson is in there quite a bit, right? Because, of course, they're administering the drug over and over again, right? And then there are a couple of other patients here. It's not necessarily in order of the patients, though. If you take a look at something else, like say this one, right? That's all over the place. David Thomas is there twice, but he's also down here, right? So it's not in any particular order, right? Patients can and will appear multiple times because they receive the medication multiple times. We've provided code that loads up all the data files in a data representation. So let's go ahead and take a look at that now. First of all, we've got an enumerated type for blood types, A, B, AB, and O. We've got an enumerated type for each one of those medicines, right, in that order. Right? We've also got a struct here called patient data that keeps track of the UUID, first name, last name, blood type as that enumerated type, the date time as a character array, a string, the dosage as an int because it's full milligrams, it doesn't get any below milligrams, and then the medicine that they were given. We've got a bunch of helper functions here. For example, if you gave me a string that is a blood type, then it'll return the enumerated type version of that. And likewise, if you gave me the enumerated version, it'll return the string representation of that. Okay? String to medicine and medicine to string as well. And then patient data and patient data, printing patient data, loading patient data from a particular file, and then a bunch of comparators here that we're suggesting that you probably want to implement. We didn't actually implement those for you, right? Instead, we left those as to-dos, right? As a strong hint as to what you should be doing, right? We're probably going to want to compare it by UUID, by date time, by UUID, and then date. So in order of UUID, so that all the patients are together, and then it's in order of when they got those dosages, okay? All right, so let's come back over here and start looking at the reports that we have to do. Our first task is to produce a report on the total number of doses and the total number of milligrams for each medicine type. So for example, in no-diethol, there are 39 doses, and there were 5,230 milligrams. Right? Kepliva, Expensive, and Placibitol as well. Right? So we don't need searching and sorting for this one at all, right? Because we're going to look at every single record anyway. So we might as well just iterate over all the records, count up the number of no-diethol, each one of the 4 medicines, right? We're going to keep incrementing a counter here. Now, what I could do is I'm going to end up printing 8 things, right? What I could do is I could create 8 different variables. Right? Is there an easier way of doing that, though? A clever way of doing that. Remember that each one of these medicines is a enumerated type, right? Let's go back over to that and take a look at it really quick. Right? So no-diethol, what value does the no-diethol have in my C program? 0. What value does Kepliva have? 1, 2, and 3. That suggests that I could use some sort of a array of size 4 to keep track of each one of these, right? So the number of times that it was administered, and the actual dosage of each one of those administrations. So let's come down over here, and let's go ahead and create those integer arrays. Int doses, right? And that's going to be of size 4. And I'm going to go ahead and initialize that to 0. That's a quick way of doing it. Here's a better way of doing it, or at least a more explicit way of doing it. If you just provided 1 0, it would actually zero out all the bytes. That's a trick that some people use. I don't like tricks, so I'm not going to use it. Dosage is of 4 is equal to 0, 1, 0, 0, and 0. Right? Otherwise, if I had just created that without initializing it, what values are stored in doses right now? Who knows? If it's garbage, then garbage plus 1 is going to still be garbage. Right? So I'm going to initialize all those. Now let's iterate over the records. We'll come back to the secondary records here. That's the 4th report. Let's look at all the records for now. All right. For int I equals 0, I is less than num records, right? I plus plus. Now again, we're using this load patient data here. The first command line argument, that first file, and then it returns the number of records in a pass by value, pass by reference, variable. And then these are the actual records, right? So I need to look at the ith record, and I need to look at what type of medicine it is, right? So let's bring this over here. I could create this and say medicine M is equal to records sub I dot or arrow to get its medicine. Right. Let me split screen this. There we go. And I can give myself some more real estate. Right, there we go. All right, so dot medicine, is it? Yep, medicine. Right. So dot or arrow here in this case. Dot because it's a regular old indexed value, or indexing it makes it into a regular old structure, right? So I've got the medicine. That gives me the index, right? I could say doses sub m, right? Because at the end of the day, it's a integer. So I can use that and say plus equals 1, right? Because I get 1 dose of that medicine. And then dosage is of m plus equals, for that I'm going to have to pull out the dosage here. So records sub I dot dosage. Right? Then I need to produce this report here. Right? And I've already got the first part up there, but I'll go ahead and bring that down here. There we go. And I'll do the same tricks that I've done before. There we go. Of, what was it again? There we go. Printf. There we go. And then replace this with %d, %d. Right. Replace this with %d, %d. Right. Yeah. I was thinking I could save on some typing there, but no, it's not going to save me that much. %d, %d, and the line. There we go. And the line, and the line. And that one, I'm not going to print anything else, but this one I am going to print what? I wish I could do something like this, doses, and have it work, just work, right? But I can't do that. I've got to go for the first one, and then I've got to go for the second one, oops, and then I've got to go for the third one, and I've got to go for the fourth one, sorry, right? Okay. And then I can actually grab all of that and change it from doses to dosages, dosages, and dosages. You could also have potentially just gone into a for loop for I want 0 up to 3 and done that, but this is just as easy. So let's see if this works actually. GCC, there we go. A.out. Now when you do A.out, you have to provide these two test files that I've already provided. A and data test B. All right, we'll understand B here in a second. That's the 4th report. And there we go. So 39, 52, 30, that matches the handout, I believe. Right? And we're good. I also gave the output, the expected output here, just to make a comparison, and that looks right to me. Right? It's not completely aligned, but oh well. Right. Okay, let's go back. Let's get rid of that for now. All right. Second report. All right. And this that was worth 20 points, by the way. How much total here? It looks like 140 points or so. I don't know how much it was at the time. Second report. Blood type counts. We need to verify how many unique patients are in the data and how many of each blood type we have for further research. In other words, how many patients are blood type A, how many are blood type B, etc. Take care. The same patient identified by a UUID may appear many times in the data and should not be counted more than once for this report. Okay? So, remember that whoever it was, Jeffrey Anderson there, he's blood type O. I should not be counting all of those instances. All right? Ideas. Remember that you can't assume in general that it's going to be ordered like this, but I could sort it by, say, UUID. And if I did, then that means that all the Jeffrey Andersons would be together, all the Erica Garcias would be together, all of the Brandy Sanders would be together, etc. So let's do that first. If I Q sorted the records, and there are num records, right? Because that's what we gave as a variable, and each one is of size patient data. Right? Then I need a comparator to compare it by UUID. By UUID. There we go. Now we actually have to go over and implement that. So let me pull this up. Remember that we put in a to-do here. All right, so what's my first step in a comparator? Yep, cast it. And this is going to be patient data, const patient data star x is equal to const patient data star A, and then B and Y. Now I can actually compare their UUIDs, which are being stored as strings. So just simply return strcmp of x's UUID and y's UUID. Right. Now why did I use the arrow there? Because again, they are pointers. Okay. All right, so let's come back over here to my report. Once they're all together, how does that assumption, or now that's not an assumption because I enforced it by sorting it, how does that help me? Right? Let's come up here to the top. Jeffrey Anderson, he has blood type O. Increment the O counter. But what about the rest of these records? 1, 2, 3, 4, 5, 6, 7, 8, 9. I should skip them all, right? So, skip them. Okay. How am I going to skip them? All right. Let's come over here to report. Ideas?
Check the UUID.
Yeah, so if the UUID is the same as the previous one, or while I have the same UUID, I should go on to the next. Once I hit the next person with a different UUID, then that's when I reset and I go, okay, well, count them. Now go next until you get to the one that you're looking for, or to the next one, basically. Do I know up front how many I'm going to be doing here? How many I'm going to count? Nope. So that suggests to me a while loop. All right. So let me go ahead and create an index here, first of all. I'll call it index, just to offset it from I, right? And I'll start at 0. While the index is less than the num records, right? So I'm going to go through all the records, right, regardless of if they're duplicates or not. But inside of that, I'm going to look at, well, here's my current record, right? And while that and the next one have the same UUID. So while current record and next record have same UUID, what I'll do is I will increment my index so that I'm getting down to say the last one, all right? Because then the next one, that's going to be different, okay? So current record is going to be records sub index. And what's the next record? Records of index plus 1. Now, while they have the same UUID, didn't I just write a comparator to do that? CMP by UUID, right? That one and that one. While they have the same UUID, What's that comparator going to return if they have the same UUID? 0, right? Now be careful here. This is a regular old structure, and it requires a pointer to that structure. So what do I do in front of it? Ampersand and ampersand. And also you need to make sure that you're not falling off the edge of the array. So what I'll do is index is less than num records minus 1. And, oops, too much Python there. All right, now why do I need minus 1? Because that last record, I need to count it. What I'm doing here is I'm looking at Paul Anderson or whatever he was, and I am skipping all of the records except for the last one. That's when I actually count it, right? So increment blood type counter here, right? And then I go on to the next record. What would be index plus plus, right? Okay. I want to make sure that I'm not falling off the edge of the array here, because I know that I'm going to increment it one more time here. Okay. I'm skipping all the way to the last record, and so it could be that the last record is unique. There's only one, right? And I want to still count them. Okay. All right. So I need a blood type counter here, right? Same trick as before, right? If it's A, or A, B, A, B, and then O, and I've just learned the other day that there are actually many more blood types than that, right? We all know positive and negative, is it? But even there's others beyond that. They're more or less compatible for blood transfusions, but apparently there are more. So blood type counts, right? And I will make this of size 4 because at least for our data, there's only 4 blood types. 0, 0, 0, and 0. Same trick as before. Now I need to increment the blood counter here, right? Okay. And that's just going to be BT counts of whatever, plus, plus. And this is going to be records of index of dot blood type, right? Remember the same trick as before. This is going to return an integer, 0 through 3, right? And so I'm just using that directly as the index directly in here. Before what I did to explain myself is I stored that off in a variable. You don't need to do that. You can just use it directly in here. All right? And then let's produce this report right here. Okay. So paste. Again, type. Nope, that's it. There we go. Printf. There we go. %d. You can make it look nice if you want to. And then %d here. And then what I'll do is I can still do with this. Nope, come on. Nope, wrong one still. Come on, it was working before. There we go. End the line. There we go. And so for A, it's going to be blood type counts. So 0. Blood type counts of, and again, you could have done this as a for loop if you really wanted to, and then use those other functions that we provided to convert the number into a string. What about this last one here? It's going to have to be the sum of them, plus 1, no comma, plus 2, and plus 3. Too many pluses. All right, GCC, oops, too many pluses still, and too many commas still. There you go. Oh, what? It was there. GCC utils.c and report.c. You're in there. Say what? Oh, I do. UUUID. There's no such thing. UUID. Oh, there. Got to spell correctly. All right, so let's run that again with those 2 test files. All right. 2, 4, 3, 4, and 13 total. 2, 4, 3, 4, 13 total. So pretty straightforward, but this one, I mean, this one was really easy, right? That's why it was the first one. This one was a little bit, very similar, but a little bit of a twist because you need to filter out some things, and that would require, doing it smartly would have required that you sort it. And then finally, performance outlier report here. Nope, I guess, yeah. Okay, yeah, this is, we could skip this. No, we've got plenty of time. A researcher has reported some remarkable results in a patient that was administered a drug on this particular date at this particular time. Right? First, find and print that record in the data set with that date time, right? So that we know who it was. Right? We just know the time and that's it. Second, the company would like to validate the researcher's observations by taking a closer look at all patients that were given the same medication within a 3-day window. So in other words, the previous day, any day, anything that was administered on the 21st, the 22nd, or the 23rd. Okay? Your report should look something like the following. It looks like it was Betty Groff that got that medicine. And then the 3-day window here is going to be either 21st, 22nd, and 23rd, everybody that got that same medication, right? I guess no. Don't assume that it'll always be keep Liva in the first one, but it should be the same throughout, right? So in other words, if somebody else got a medicine on the 22nd, but it was no diethol, then we don't want to report them. We want to report that it's the same medicine here, I think, right? Is that right? Let me double check. I think so. Yeah. Yes, it needs to be the same medicine. Otherwise, we're going to get a whole bunch of other stuff. Okay. All right, so suggestions on how to do this one. First of all, how do I search for that particular patient that got that drug at that exact time? I would want to sort it by time, and then how would I want to search it? This is something we're not done with grading yet, but the grading in the main section, we saw a lot of instances of people just rolling their own and doing linear search, like for the New York or for big airports or whatever, right? The whole point of that was so that you could sort it and then use B-search and not have to write your own code to do it, right? So we're going to not write our own code to do it here, right? We are going to, if no such dose, you don't need to print any other doses, right? Instead, you print this out, right? So I need to first sort it by date time. That means qsort, and I'm going to grab a bunch of stuff from up here. There we go. And instead of by UUID, by date time. Oops, date time. That means that I need to actually implement that now. How am I going to do that? Same thing, but instead of UUID, date time, and date time. And because it's ISO 8601, that'll be in order, like oldest to most recent, okay? No reason to print it out though, okay? So now I need to find that record. I'm going to make a call to B-search. Now remember, the first 4 are always going to be the same. I guess the first 4 of qsort are going to be the same as the last 4 of B-search. What is the first thing I provide over here in B-search? A dummy key, right? So what I need to do is I need to create a patient record, right? So patient data key is equal to, remember that I've already, did I have a function to do that for me? I guess it's a init. Okay, fine. And so I'll create a key, and then I will init it. Why did I not make it a pointer? Because I actually need the memory, right? And then I'm going to pass it by reference, right? And then what do you need? I shouldn't have. I'll split screen it over there. Do I care about the UUID? Nope. I can pass in null or null or an empty string, right? It doesn't matter. Let's go ahead and go with empty string. That might be safer. First name, last name, I don't care about those either. The blood type, I don't care about that. Although, well, blood type, in fact, if any of those are null, okay, so they can't be null. So what happens with blood type? String to blood type, and then what happens if I pass in an empty string? Okay, yeah, it's a dummy value of -1 apparently. All right, so let's go back to init patient data. Oops, no, over here, init patient data. All right, so date time is the one I do want. And then finally the dosage, I'll just set that at 0. Now the date time that I want is this guy right here. Right? It's got to be exactly equal to that right there. Okay? And now that I've got my key, I can go ahead and pass in my key. Why am I putting an ampersand in front again? Because you need to change it into a pointer, exactly. Now bsearch is going to return a patient data star result, okay? If it's successful. If it's not successful, it'll be null, right? So if result is not equal to null, then we can go ahead and proceed with our report here. Otherwise, else, no such dose, and so what do? I'll use that code that we were given and print out no such dose. All right, so if no such dose. All right, so I found it. I found the record. So let's print out the record. And remember that we gave you code to do that. Print patient data. And let's go ahead. Come on, I don't want, there we go. Print patient data, result. Do I need to put an ampersand in front of that, or do I need to dereference that? It requires a pointer already, and result is a pointer, so we're good to go there. Let's just make sure that this is working. I'm pretty sure, oops. Darn it. Oh, date time. Okay, fine. It's capital T. I guess that makes sense. I always go with lower camel casing. Clear this. Still some other problems here. In too few arguments. Did I get them wrong? All right, fine. Init patient data. So there's the key, UUID, first name, last name, blood type, date, time, medicine. Oh, and then dosage. Okay, fine. Medicine and dosage. Okay. GCC that. And let's run it again. Do we at least get that outlier? Yay, we got Betty Groff. And she took Keep Liva. Right? So now what we need to do is we need to go through and find all of those that begin, or that I should say, that are on the 21st, the 22nd, or the 23rd. And I gave away how to do it. Right? How are we going to do that? I'm going to look at the date timestamp, and then what? If it begins with 0220621 or 22 or 23, then I'm going to report it. And it has the same medication here. Okay? Now, you could be clever about this, and you could say, well, okay, what's the index? Use binary search in some way, or pointer arithmetic to say, well, I'm already at that medication. All I need to do is go back until I'm on the 20th, and then I go forward until I'm on the 24th. Right? I could do that. Right? I'm not going to even try to be clever here. I'm just going to go ahead and go over all of them. Right? For int I equals 0, I is less than num patient or num records. Num records. I plus plus. Right? I'm going to check if the ith record starts if records sub I dot date time starts with 2022 06 and 21 or 22 or 23. How do I do starts with in C? Now if you were in Java and you had a string, you could go dot starts with. Right? I don't have starts with in Java. Instead, in C. Instead, I have something else. I could use strcmp, right? I could say if strcmp of records and this string right here is equal to 0, right? That kind of gets me there. doesn't get me all the way though. Why? Because the entire date timestamp has a time on it as well. It's not going to be equal just by looking at the first, what is it, 4, 5, 6, 10 characters. Right? So how could I restrict it to the first 10 characters? There was another version of strcmp, right? What was it? ncmp. That takes an additional argument. The number of bytes, the maximum number of bytes to compare. So it's just going to compare those first 10 bytes, those first 10 characters. Should it be 10? 4, 5, 6, 7, 8, 9, 10. Yes. So if that's 0, then that means that you found something that was on that date, regardless of what time it was. Or, what else do you want now? Copy that. And let's move over so it's all aligned. The 22nd. Or the 23rd. There we go. So if any of those is correct, then we found the one that we're looking for. But you also need and what? And I've have too many parentheses there, so there we go. We want to know that they have the same medicine. So records sub I dot medicine. Medicine, did I spell it right? Yeah, it looks right. Is the same thing, it matches the results medicine. Right? Betty Gross medicine. Now, what is matches here? Medicine is a what? Not a string, it was, let's move this over here, there we go. Medicine is an enumerated type. So how do I compare medicines? Same way I would compare any integer, equals equals. Now, how do I get the results medicine? With records of I use the dot operator because it was a regular old structure. But result is a pointer, so there. I need to know that those are the same. Right? So if that's true, then we go ahead and print the patient data of records sub I, and remember that we have to put an ampersand in front of it because it requires a pointer. GCC, run it. Are all those the dates that we're looking for? 22nd, oops. Were we also looking for the 21st? Maybe there's nobody on the 21st. Oh, there is one. All right.
Said it was not stored when it was printed to the
Say again.
like the 21's there, it's just in between through 22.
Oh, okay. Weird. That shouldn't happen. Oh, because I'm still ordered by UUID, right? No, not UUID. Is it, what did you say?
So the top one's the performance outlier, I'm pretty sure. So that one's supposed to just be separate.
Oh, that's right. All right, so what should I print between them? Other doses, 3-day windows. All right, fine. Printf. Now it's going to look exactly like it. Hopefully. Yeah, there we go. There, now it's in order. Thank you. All right. All right, we've got 15 minutes left here. This is actually probably the best one. I always like putting something like this in here. So we're actually given 2 files because the data provided was actually compiled from several different sources, including entered by medical professionals, some reported by patients, I took this at such and such time, and some from inventory records. It's possible that dosages were reported incorrectly. For that reason, LSP Inc. has compiled a second set of data and wants you to find any differences between the 2 data sets. In the first data set, the same one that you used to produce the above reports, for each record, find the record in the second data set identified by UUID and date time, so that's our unique identifier there, and report it if either the medicine or the dosage is different. For example, April Long here. She took no diethol on that exact date and exact time, but one of them reported 220 milligrams and another reported 210 milligrams. They're not equal. Okay? Here's the incorrect medicine, an instance of Brandy Sanders here. On that particular date, took 180 milligrams and 180 milligrams, but one report says it was expensive and the other was that it was no diethol. Okay? we need to report all incorrect dosages, medicines, et cetera, and then count them all up. Okay? All right. Help me out. Bad dosage data. So if I need to match records based on UUID and date time, now what do you think I need to implement? UUID, then by date, right? So, utils, ideas. I'm scrolling up here as a strong hint. I've already got 2 functions to do each one, right? Couldn't I just reuse them? Int result is equal to CMP by UUID of A, B. Now, if that's 0, then we know that it's the same patient. So we now have to look at the time, the date time, right? If result is 0, then return, or the result is equal to this other comparison, date time of A, B. Now, they might be the same. That's okay. It doesn't matter because they're going to be the same records then. So return result. Okay? Cool. Let's come over here and let's sort them both. Right? Now, remember, the 2 that I have are records and secondary records. Note here that it looks like we made the assumption that they're going to be exactly the same number of records. I've done variations on this in the past where, there's actually a missing record. It's in A, but it's not in B. And then it's in B, but it's not in A. Right? In which case you would have a different number, potentially a different number of records there. Right? So now I'm going to go ahead and sort both of them. Qsort records and num records and size of patient data. And what the comparison I just wrote was called CMP UUID date. And I'm also going to sort the secondary records. Secondary records. Right? Now let's outline this. For each record in records, right, find the record, the same record in secondary records. Right? And what are you going to report? If doses are not equal, then are not equal, then it's a bad dosage, and report it. If medicines are not equal, bad medicine record, medicine record. Okay, and either way, after you're all done, report both totals. Okay. So that means that I'm going to have to keep track of this. Int num bad dosage, I guess. And int num bad medicine. Good on that? Or what should I be doing? Always initialize it. Right? Now for each record in records, well, that one's easy. For int I, this is your idiomatic for loop. I equals 0, I is less than num records, I plus plus, right? Now I want to look at, I need to find the same record in the secondary records, right? So I'm going to use bsearch again. Right? So patient data result, or I already used result, right? I can reuse it. Result is equal to bsearch of, I need a key here now. Do I need to make a dummy key though? I have a record, records sub I. I'm searching for that needle in the second haystack. So I pass in the rest of this stuff here, secondary records, all of that. There we go. All right. But what do I need to do to record sub I? Make it into a pointer. Now, if result is not equal to null, then I found the record, right? Otherwise, if it were equal to null, then you'd have a missing record. But that's not part of the test, right? We're not making that. We're making the assumption that all the records are there. All I did was jumble them up and then change a few and then jumble them up again so that they would be needles in haystacks. Right? So if the, I could, however, else printf error, I always do this anyway, just as a sanity check, could not find the record. Otherwise, it won't print out anything and I won't know anything went wrong. Right? Okay? Otherwise, when I'm done with it and it works, I'll come back and maybe erase that or something. Okay? All right, so I found the record. What do I do now? I check the doses. Right? So if the result dosage is not equal to records of I dot dosage, then I report it as incorrect dosage. Printf incorrect dosage and the line, and then I report those two records. And I've got a function to do that, right? What was that? Print patient data. And I'll print patient data of records sub I, and then print patient data of result. Now, once again, why do I need to put a ampersand on one and not on the other? Because one's a pointer and one's not. Right? Okay. Else if, or they could, I guess they could be both be wrong, right? The dosage could be wrong and the medicine could be wrong. So let's just go ahead and go with an else if here, or an if here. So this is a medicine, incorrect medicine, right? And that's it. Right? Oh, and then I guess I need to increment my counters, right? Bad dosage, plus plus, and bad medicine, plus plus. Okay. At the end, let's go ahead and steal this this typing at least, right? For the final report, after I'm all done, and I can get rid of this cruft now. There we go, and come on, there we go. And is it really worth it to save on typing that? Printf, there we go, and then %d and the line. And this is bad dosage. But this one is bad medicine. Okay. Moment of truth. Hey. April Sanders, April Long, Sanders, Anderson, and Anderson. And it looks almost exactly the same there. Okay. Now, this was designed so that if you did it naively, like let's say using linear search and not searching and sorting, that it would not be possible because here's a full, okay, so I'm not going to open it. It's not even allowing me to open it, but there's 10 megabytes there, right? And that 10 megabytes, if you are doing linear search, it's not going to execute within the 5 minutes because you're going to be doing, say, 10 million records times 10 million records. That's 100 billion operations, right? So we needed you, or we were testing you to see if you'd actually use bsearch properly. Right? That happens all the time. It happened yesterday on Advent of Code too. Anybody been doing them? No? Okay. Well, there was this grid, this simple grid, and of course the example is always small, and so you can go ahead and print it out or whatever, but then the actual example was like 100,000 by 100,000 grid. And so if you were, if you kept track of every single point in this grid, then that's 10 billion elements, right? And it's probably not running, right? All right, so there is the final exam from 2023. Now the H version of that also had a starter code for a Java version, and I think both of them were required because once you did it on one, then it was pretty straightforward, especially on Java, it was pretty straightforward. Right? Okay. But once again, you will not have any Java questions on your multiple choice exam. Instead, it's just C. Right? How was the lab yesterday? Everybody did pretty okay on lab. How was the AI usage though? Was it helpful, or did you have to fight it more?
Yeah, the first time I ran the AI, it switched everything to long longs.
Okay, I can see that, but that's it? Or
Well, it did a whole bunch of other things and like completely rewrote the whole code. That is not why I want it.
Did it rewrite it so that it was correct?
Well, I just said, did I miss it? I think it was, but it was all long ones instead, so it wasn't gonna work with everything else.
Ah, okay. All right, so it's still wrong, basically.
Yeah.
All right, yeah. When we put that together, maybe a couple months ago, at least for the version 4.0, it got extremely confused by like it fixed like 3 of the bugs, and then the 4th bug it couldn't get, and it actually kept second guessing without any additional prompts. It would go, wait, that's not right. Wait, that's not right. And so it was a great project to show you the limitations, and hopefully they haven't updated the model so it still struggles. Yes.
My AI kept giving me incorrect tests.
Ah, okay. Yes, that was another part. It didn't know what a Capricar number was because it wasn't referencing the correct thing. Then we have you give it the.
You give it the correct numbers, and then it does fine.
Yes. I think that's because it might have been trained on a different definition of Capricar.
Maybe.
Because there are 2 of them, but there's the one that we're using. Right? Okay. All right. Well, let's see. We're doing pretty good on the response rate. I think we're up to 70% or so, but make sure that you're completing the student evaluation, the course evaluation, so we can bump that up to 100%. And then I haven't looked at it lately, but at the beginning of the week, there were at least 4 people. I don't think anybody from this section, though, yet, that had won Battleship games. So it's definitely doable, and the server is up and running, and it's fine. So have you won? Oh, okay, good. Did you play it manually, or did you have the AI, write AI?
I use the AI, like to create like a grid.
Okay.
I just typed in. Like,
All right, so you had fun playing it. One person did that, but then they said, give me an option to play it manually or to just solve it using AI. And then that's where they said that it took the longest because, I mean, the obvious solution is just to, grid, carpet bomb or whatever. And then once you get a hit, probe up, down, left, right, or, and it couldn't figure that out, how to do that properly. So I think he gave up on it eventually and just, all right, fine, I'll just play myself. So good takeaways there. Right? All right, so I'll see you next week, Tuesday, for the final exam here in this room. I think it's 10 a.m., but don't quote me. All right, have a good one.